So exercise rate and order of the reaction. The first structure questions, about 6 questions I have already discussed. The structure one, so we'll begin with question 7. The question 7, you can see methanoic acid is reacting with the bromine to react, which give H plus and bromide ion and a carbon dioxide. The kinetic of the reaction can be varied by different method. For two different method, name substances, identify a method of the following. The progress of the reaction, the method given should be different from each for each substance and should not involve taking a sample from. So we cannot mention any quenching, we cannot mention here. So which method we can use here? If you see bromine, aqueous bromine, it is colored. Aqueous bromine, this is a colorless, acid is a colorless. This is colored substance, this is colorless. This colorless and carbon dioxide gas will escape, so it is also colorless. So means there will be a color change. We can observe a color change. So one thing we can mention is like observing a color change. Then what else? The gas is given off here. As you can see, there's a gas which is released or a gas is given off. So we can measure the volume of a gas. Because for this question, we have to determine a substance like a technique which we will use. So the substance here, we can mention a carbon dioxide and a method what we will do, we'll measure the volume of a carbon dioxide. So when we measure the volume of a carbon dioxide in a unit time, we can determine the rate of a reaction. All the values should be with reference to a time or change in volume of a gas or measuring a volume. Then bromine is there. So substance, you can see a bromine. And if a bromine is there, so we can use a colorimeter as the color will change. Electrical conductivity can also be used. As you can see, first we have like few ions, but then we have more. So the presence of the bromide, the substance will be like bromide and hydrogen ion and change in electrical conductivity. We can also measure the rate or the speed of a reaction. In an investigation of the kinetics of the reaction, a large excess of a methanoic acid was used. Why we use a large excess of methanoic acid? Because we were finding a rate with respect to bromine. Like if I am finding a rate with respect to bromine, so bromine should be a limiting reagent and the other reagent should be in excess. So the change in amount won't affect the rate. So only the limiting factor will affect the rate and we can determine the rate or the speed with respect to bromine. So we have the time and the concentration of a bromine. As you can see, a graph is there. So you have to select a suitable scale for this graph. And then you will check like what happened. So we will, you can clearly see that the concentration of a bromine, it's a reactant. So concentration is decreasing with time. So how we can determine the rate with respect to bromine? So on y-axis, we have a concentration of a bromine. So on the y-axis, we have a concentration of a bromine. On x-axis, we have the time. And Then you will like selecting a suitable scale, then it depends on the shape of the graph. If you have a graph which is a straight line, what this indicate? This indicate that rate is constant because the gradient represent the rate. The gradient is constant, rate is constant, and means this will be zero order with respect to bromine. If the graph, the lines after plotting, if it is a curve, if it is a curve like this, and then if the half life is constant, not only a curve but the half life should be constant. If the half lives are constant, it means this will be a first order. But if it is like a shorter half life at the start and then it get longer with the passage of the time, so it means that this will be a second order. So first you will plot the, like mark those points, selecting a suitable scale, finding those points like the coordinates, and then plotting a line through those points. It might be a straight line, maybe a curve. Depending on if it's a curve, it can be first or a second order. If it's a straight line, it will definitely be a zero order. So it totally depends on plotting these results. I'm not plotting the results, I'm just giving an idea that how you can estimate, understand, like how you can find the order of the reaction. Use your graph, confirm that the reaction is first order. So they mentioned that, so what should be the, and how, like how we can show that the reaction is first order, as we have just discussed. If it is a first order, then the shape of the graph, so it will be like this and with the constant half-lives. So the half-lives will be constant. Then under the condition of the experiment, the order of a reaction with respect to methanoic acid appear to be zero. Explain why this case. Why it is zero? Like the change in concentration of a methanoic acid does not affect the rate. As you can see in the beginning, how much what we took a methanoic acid, we took to investigate this, we took a large excess of a methanoic acid. Like methanoic acid is more than what is needed. So the change in amount of the methanoic acid will not be like large, or a very small change will be there. So the answer here you will mention the change in methanoic acid or a concentration of a methanoic acid won't change much, because the concentration is what? Concentration is moles divided by volume. You use a large, high, very high concentration, so it will appear even the moles are changing, but it won't affect the concentration much, because like if I say the moles was 1000, if 1000 become 90, like 9000, if moles were 1000 and become 990, so that change is there, but that change won't affect the concentration too much. Or if the let's say moles were 10,000 and 10,000 become 9,900, so if it become 9,900, so that is again not affecting the concentration too much, because the change is negligible compared to the amount which we have. Then use your half-life, deduce the order with respect to, sorry, this is, we jump to next question. This is question 7 we were doing. Yeah, this part we did, part 3. No, I was just giving an example, because if we took something in a very large quantity, the concentration is so high. So concentration depends on moles and volume. If the concentration is so large, even the moles will change, but the concentration won't change too much, because the change in the moles is negligible. So under the conditions of the experiment, the order of reaction with respect to methanoic acid appear to be zero. So what is the reason for that? The reason is the concentration of a methanoic acid is very high. So the change in the concentration will not be considerable. Like it will change during a reaction, but that change is very small. So that's why it's almost zero order with respect to methanoic acid. Further experiment shows that the reaction is actually first order with respect to methanoic acid. Then we already like, so what will the rate equation? Rate is equals to K times concentration of a methanoic acid and the concentration of a bromine, because it was first order with respect to bromine and it was first order with respect to methanoic acid. Then the initial rate of a reaction was carried out was, so this was a rate is given to us, this is given. The initial concentration of a methanoic acid is this and bromine is this. We need the value of a K. So if I need the value of the K, if K is our subject, so K is equals to rate divided by concentration of the methanoic acid and the concentration of a bromine. So this will be 4.54 into 10 to the power minus 5 divided by concentration of a methanoic acid 0.5 and concentration of a bromine 0.01. So when you divide, you will get the value for K, which is, you can annotate on the screen. What is the value for the K? 4.54 exponent negative 5 divided by 0.01 into 0.5. What's the value for K? It is 9.08, okay, into 10 to the power minus 3. Okay, 9.08 into 10 to the power minus 3. That is the value for K. But we also need a unit. What about the unit of the K? Look, the unit of the rate is what? The unit of the rate is moles per dm cube second inverse. And unit of the concentration is what? It is moles per dm cube. And unit of concentration is what? Mole per dm cube. So this cancel out with this and this will go through the numerator. So this will become dm cube 3 mole raised to power minus 1 second raised to power minus 1. So that will be the unit of K. dm cube 3 mole minus 1 second negative 1. Is it clear, this question? So this is about the rate and order of the reaction.